Alright, I'm Ryan Connors, and welcome to the BotWorld prototype. Initially, you will launch into the lab hub. This lab hub is an evolutionary room that will expand and aesthetically change as the player progresses through the game. For the prototype, however, it contains only three transitions. The cart will transition you to the actual physical bot generation. The box in the top left will transition you to the AI generation. And on the top right, that will transition you to the mission selection. It's worth noting that this room actually isn't one continuous quad. It's segmented into cells so that the lab can be created modularly. So there's actually a distinct corner prefab, there's a center floor prefab, and there's various small prefabs, all of which cumulatively come together to create the room. But that being said, let's take our little source 1 missing texture player and move to the bot fabrication. So in bot fabrication, we have a simple scaling UI, a model viewer on the right, and a list of components that we can use in the bot. On the bottom, you'll see a bunch of mounts, all of which are active buttons, but only some of which will actually be used when generating the bot. For the prototype, there's only one component of each category, the goal of which well, the reason behind which, rather, is mainly because of the time constraints involved with modeling all of these assets. And secondly, because the goal of the prototype was to showcase how the actual bot identification works, not so much provide a diverse array of bots for creation. So that being said, we'll take our first chassis. Here it is. You can see it has various mounting points on it. Let's say we want to select the arms. We'll select those mounts from the mount selection window and hook our lasher arms up to them. We'll do the same with the propeller, the reactor component, and the processing unit, and finally the memory piece. Here we have our completed bot, which we will save. The way that this is actually done in Unity is there's a chassis object. There's a parent object for it, which stores all of the bot information, and the chassis has various empty game objects that are stored relative to the core of the chassis that have transforms that will dictate the spawn location whenever we instantiate new components onto that bot. Once the bot is manufactured, the whole thing is saved and can be moved forward to the actual AI generation, which we'll showcase now. Alright, so here we have the bot that was saved, and we have the set of labels that are available in the prototype, as well as the actual label mounts and weighting associated with those slots. So, let's say for example, we've noticed that red blood cells tend to behave friendly, as one would expect, while rhinoviruses have characteristics such as white and circular and tend to behave in a hostile fashion. So what we'll do is using that information, we'll select a red label for our first slot, and we'll give it a positive weight, indicating we probably think that if something's red, it's friendly, which we can associate back to the red blood cell. In the second slot, we'll put disc-like, and in a similar fashion, we'll give it a positive weight, since we've noticed red blood cells are disc-like and red, and they tend to behave in a friendly fashion. Finally, we've noticed, let's say that rhinoviruses are white and tend to behave in a hostile fashion. So we'll go ahead and assign that a negative weight, and we'll save that and close out. And I apologize for any of the background noise. I don't have any control over that at this time. Alright, so we'll save the labels, and we'll head over to the actual mission deployment. Alright, so here we're brought into the showcase mission, which has a basic random reflex agent tied to each of these entities that will wander in various directions just for the purposes of showcasing. So we have our core bot, which would normally behave autonomously during gameplay and will encounter various cells by essentially colliding with them. They have a trigger radius associated with them that the bot can sense their characteristics within. So we've encountered this cell, which I know as developers a red blood cell, and we can see that the labels that were triggered in it were red and disc. So this cell obviously has the characteristics red and disc, but does not have the characteristic white. Those labels that were triggered add their values their integer weight, to a running total, which is then returned by the bot, along with the determination. In this case, the weight is positive, so the bot assumes that the cell is friendly. So let's go take a look at the opposing entity. We've got one that's stuck up here due to the constraints of writing AI in a couple weeks. Here we can see the red and disk were not triggered, but white was triggered. So the resulting score is negative, and the determination is thus enemy. In the runtime environment of the actual game, the bot would naturally begin to destroy any of the enemy entities that it had encountered, even if this was erroneously assigned to, say, the red blood cells. That pretty much showcases everything. From here, you could either intrude, which would take you back to the AI generation screen, where you could change the weights on your labels. So if you notice some erratic behavior, some things that were incorrect, you could make alterations up to 3 times in the course of a mission and do so. Once your mission was complete, once all the enemy cells were destroyed, you would be rewarded with cash that you could use to upgrade your bot and assign new labels or to conduct research with. Thank you for taking the time to look over this, and I hope you have a good day.